almost reached the end of our first packet. Use the power series template to find a power series for 1 plus x squared. So we already know how to do that. We could maybe over here to the left, we can write 1 over 1 minus a negative x squared. So we know that the first term is 1, and then the common ratio is negative x squared. So we have 1 plus negative x squared to the first power, plus negative x squared to the second power, plus and so on, and we are getting really good at this, hopefully. Plus the nth term, so we have negative x squared to the nth power, plus dot dot dot, equals, and let's make sure we have room for that. The sigma notation, we're going to start n at 0, go to infinity, and then we can use our negative x squared to the nth power. We'll talk about that in class, how to split that up a little bit. But just so you get it in your notes, we can split that up like this, negative 1 to the n times x to the 2n. So that makes it a little bit cleaner looking, separates the negative from the term with the x. And so then, once we get that all expanded, then we're going to go ahead and integrate both sides of the equal sign. So let me get a different color here, because I know that's going to be a lot better for you. So when we integrate 1 over 1 plus x squared, we get, that should be something that rolls right off your tongue. You've got that at the ready. Integral of 1 over 1 plus x squared is the inverse tangent of x. And then, you know what would be really helpful here is actually rewriting the first few terms so it makes it easier to see. 1 minus x squared. This makes it easier to see the pattern. And then when you simplify each of these terms, it makes it easier to actually integrate. So we have 1 minus x squared plus x to the 4th, because it's squared, the minus sign is being squared, minus x to the 6th, and plus, and so on. Okay, we'll leave that alone. So integrating 1, so the antiderivative of 1 is x, minus the antiderivative of x squared is x cubed over 3, plus then we have x to the 5th over 5, minus x to the 7th over 7, plus dot dot dot, plus, and then actually this would be a little bit easier if we could just rewrite this as negative 1 to the n, x to the 2n, because that negative 1 to the n is still going to stay with us. And then we have x to the, remember, you add 1 to the exponent, x to the 2n plus 1, and then you divide by that exponent as well. And then it should have a plus dot 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 there, plus dot dot dot. And then that's equal to, n equals, so what are we going to start n at? If we start n at 0, then that's going to make that positive. Negative 1 to the 0 is 1. X to the 1, so that's good. And then so we're going to start at n equals 0. Just check that every time. Just make sure your first term matches. If you are running out of time, do the first term only. If you got a little bit more time, then try the second term. When you plug a 1 in for n, you get negative x to the 3 over 3, and you're good to go. Okay, so you just use that same nth term right there, and you've got your sigma notation. You've got everything you need. First 4 terms, didn't ask us to do that, but first 4 terms are good. And then nth term and with our sigma notation. So that's example 12. We're going to do this, the graphing part in class. We talked about partial sums, and we actually did a little bit of that in class today. So finally, let's take a look at our last example. Given this series, write the first 4 terms in the general term. So we're hopefully getting really good at that. So we've got f of x equals n equals 0. That whole thing is to the 0 power, so we just get 3 times 1. And then plus, and then we got 3 times this thing to the first power, so 3 times x minus 1 over 2, plus, by the way, write the first 4 terms in the general term in the expansion of this this infinite series here. Those are the words that you see on the AP exam, so helpful to know that, I think. X minus 1 over 2 to the second power plus 3 times x minus 1 over 2 to the third power plus dot dot dot, and then the general term. So the general term is right there, 3 times x minus 1 over 2 to the nth power plus dot dot dot. So we did what we needed to do, 1, 2, 3, 4, and our general term. So just always double check to make sure you've got everything. First four terms in the general term for integral of 0 to x, f of x dx, well, this just means the same thing. We're going to integrate both, we're going to integrate every term in the series expansion, at least the first four terms we're going to integrate, and then write those down. So let's see, what would make it easier to integrate? If we wrote it like this, 3 plus 3 halves times x minus 1 plus 3 over, I hesitate here. Could I write 2 squared? I should probably do that. 2 squared times x minus 1 squared plus, because I like to keep the pattern, that way it's easier to get that nth term. X minus 1 cubed plus dot 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 plus 3 over 2 to the n, x minus 1 to the n. Okay, so now integrating both sides, let's put this right here. The integral from 0 to x is the integral from 0 to x, so it's the same kind of thing here. If we replaced, if we write 3x and we replace that with an x, then and subtract replacing x with 0 in all the terms, then we just get the same thing we got when we integrated every term in the last one. So whether or not you integrate, let's just make sure we talk about this here. If you just integrate both sides, then you're going to get the same thing as if you integrate both sides from 0 to x. Okay, so 0 to x is the same thing as not even seeing 0 to x there. Well, when we don't see that there, what we really are doing is we are actually integrating from 0 to x. Okay, so therefore we don't need to worry that we're seeing that 0 to x there. So write the first four terms. So we have 3, so when we integrate 3, antiderivative is 3x plus, and then we have 3 halves, that's a constant, that's not going to change, x minus 1 to the second over 2, okay, plus 3 over 2 squared times x minus 1 cubed over 3 plus 3 over 2 cubed, x minus 1 to the fourth over 4 plus dot 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 plus 3 over 2n still, x minus 1 to the n plus 1 over n plus 1 plus dot dot dot. Okay, so that's how we do it. 1, 2, 3, 4, and the general term. Determine the interval of convergence for this series found in part B. Okay, well, let's think about that for a second. This would be more difficult to find the interval of convergence for, so let's maybe look at the other one, the first series, because when you integrate both sides, you know that the interval of convergence doesn't change, so maybe the other one would be easier. And if you look at the first one, we can see that this actual series is a geometric series. So what do you mean? Well, the first term is 3. The first term is 3. And then the common ratio, you're multiplying every term by x minus 1 over 2. See? Because you have 3, then you have 3 times x minus 1 over 2, then you have 3 times x minus 1 over 2 times x minus 1 over 2. So we have a common ratio of x minus 1 over 2. And so we have to make sure that the absolute value of x minus 1 over 2 is less than 1. Okay? And how do we deal with that? Well, we deal with that the same way that we dealt with it before. X minus 1 over 2 is greater than negative 1 and less than 1. So it has to be in between these two numbers. And then when you multiply every single term by the 2, we can see that these cancel, and we get negative 2 on the left, and we get x minus 1 in the middle, and we get 2 on the right. And then if we add 1 to all three parts, we can see that negative 2 plus 1 is negative 1, is less than x, which is less than 2 plus 1, which is 3. So we have our interval of convergence for the first series, which is the same as the interval, as the interval of convergence for the series in part B. Okay, so we are done. 10 minutes, and hope you enjoy the rest of your night. Hopefully it's not 1 in the morning for you, or even later. Hopefully it's like 6 o'clock. Now you're going to go eat dinner, get to sleep early, have a great breakfast, get a lot of sleep, and not in that order, of course, but then ready to rock and roll tomorrow. We'll see you then.